So this will take us toward reliable pumps. And this is me. My name is Larry. My last name is Backus. Everything that we own, think of your car, your computer that gives good service, maybe your watch, your cell phone. Everything that we own that is reliable and gives good service has proper design, proper application, proper operation, and proper maintenance. Think of your power tools. Think of your refrigerator and your TV. Likewise, reliable pumps also exhibit or possess proper design and application, proper operation, and proper maintenance. And everybody, that means design, operations, and maintenance, must contribute to reliability. If one of the elements is absent or incorrect, one of these four, design, application, operation, or maintenance, then the reliability chain is weak. And you can see the weak link in the chain. That's the link that's going to break. Here's an example of bad or inadequate operation. The operators start, stop, and control the process pumps. Let's look at some pumps. These are parallel pumps, meaning they are two pumps side by side. Now, alternating pumps cannot run in parallel. Parallel pumps can alternate or run together, but alternating pumps cannot run in parallel. These are parallel pumps. Both pumps are turned off. You're going to start these pumps. So the process engineer says to the operator, he says, I want you to start those two pumps. Which pump do you start first? The operator should start the weak pump first. Well, you say, wait a minute, those are identical pumps. They both have the same horsepower, the same kilowatt motor, the same pump, the same, came down the assembly line together, the same impeller, the same shaft, same bearings. There's one number different in the serial number. They were bought together. One serial number ends in 6, the other serial number ends in 7. Other than that, they're identical pumps. Now, one pump will likely be the dominant pump, the other pump will be the weaker of the two pumps. You would perform right there on the spot. Don't go get your calculator and don't go get the mathematical formula and don't go get the amp meter. You would simply turn both pumps on against a shut valve for no more than 15 or 20 seconds. And the pump that exhibits the highest pressure on that valve, on the pressure gauge at the discharge of the pump, that is your dominant pump, and the other pump is a weak pump. Why is it important to start the weaker pump first? Now, we'll identify this as the weak pump. We'll identify this one right here as the dominant or the stronger of the two pumps. So let's say that we're going to start the dominant pump first, which is wrong. We should start the weaker pump first, but we're going to start the dominant pump first. So we bring in the liquid here. What happens if we start the dominant pump first? We bring in the liquid here, bring the liquid through this elbow right here, bring it into the pump and through the pump and through here, and we come right to here. But something else happens if you start the dominant pump first. Let's go back to where we were here. This is where we ended it here. Let's bring it down through here, bring it over to here, bring it down to here, and slam into that check valve right there. Now when the liquid can go no more in this direction, the liquid is pushed out here. Does that make sense? Now my dominant pump is holding that check valve shut. Now what is a check valve? A check valve permits flow in only one direction. So my dominant pump is holding that check valve shut, and this pump is starved on the suction side, and the output is likely to be reduced by the same percentage. So what is the weaker pump really going to contribute to my process? Absolutely nothing. So after this pump deadheads for 3 or 4 weeks, the seals and the bearings will fail from vibrations and distortion, and this pump becomes a high maintenance pump. And then somebody says, send those mechanics to a pump rebuild class so that they'll learn how to rebuild their pumps properly. The weaker pump can deadhead against the check valve right there, held closed by the dominant pump. Now this is operation. Everyone must contribute to reliability. It is impossible to assign 6 or a dozen young engineers to be the reliability team, give them each a vibration meter, and then expect them to bring about a significant improvement in the pumps in a refinery or a power plant or a chemical process plant. This is going to take us toward reliable pumps. This will be a guide to stop rebuilding pumps.